Are we recording?
It says recording.
Okay, yeah. So I'll share my screen and here we go. And then I'll press begin. Okay,
5 questions.
Okay, I'm not sure if they want us to show our work on this one because it just has to upload a single image. Well, I mean, technically they'll see it when we draw the tree, but I don't think we need to do the same thing as last time where we have like, we upload each picture of each step.
Yeah.
Yeah, because it just says upload an image.
Yeah. So I think we can actually just like work it out. Wait, it says with the max degree of, but it doesn't say what the max degree is.
Yeah, that might be an issue. Do you want to just assume it's 3 in the next problem?
Yeah. Yeah. We should probably just like at the top right, assuming 3 and then draw out the rest of it.
Okay. Let me. I have a Word doc, so. So I guess we'll have. Our first node will be like have like a text box.
Oh, wait, I just realized I could do this on Notability on the iPad. It might not be as hard as it would be on Word, but I don't know how I would share my screen with you guys while I do that.
Yeah, that might be an issue. We'll just try it like this for now.
Okay. I could zoom on an iPad, yeah. Let me try that, I guess.
Yeah, join and then if we need
yeah,
to.
I'll be right back.
But yeah, so we'll do this for now. So we have the value of 12 in our tree.
So I don't think I can okay. I think I'll join on my iPad on a different account and I can have my face cam on this because I don't think I can draw and have the face cam on at the same time on the iPad.
Okay, so right now we have 2 pointers. So it's m equals 2. And then I guess, so do you want me to finish? Okay, I guess paint is easier. Or I can use paint.net actually.
I'm gonna join on the iPad in a second if you just want to wait for like 2 minutes while I try to join on another Zoom account. Just give me 1 second. You can continue trying though.
Okay.
In case this doesn't work out.
Yeah. So we got so we're gonna have a rectangle. And so here's gonna be our first disk block. I guess we can like make it smaller if need be. And then we're gonna have our text in there. And then we're gonna have something like 12. Or well, yeah. I guess we have another layer for numbers. Yeah, layer 2 will be for the numbers. And then we'll have, yeah, so first node is 12. And then we're going to go to the next node, which is going to be.
It might be easier if we just arrange it ascending from the start, just because we don't have to show every step. So like there's no reason to go through it unless you want to go through it, I guess.
Okay. Yeah. So we know that, okay, so we're going to have a node of 12, 4, 9, 22. So 12, 4, or well, no, we decided it was degree 3, right?
Yeah, we assumed 3, so it would stop at
So we have
2 at the
412.
top one, right?
Yeah, so we have 412. Then we have, once we add 9, it becomes degree 4. So that would be, so we'd end up having the parent be 9 because it's in the middle and the lower node of 12. And then we'd have, we would add, what is it? 20 to the right of 9, or, well, technically they're on, I guess it's, yeah, I guess it's kind of hard to draw or type, but yeah. So we have 4 on the left of, yeah, so 4 is going to be on the left.
Real quick, Jacob,
Yeah.
it's asking me to enter a passcode for the
Um,
Zoom.
it should be in the first one that I sent. The first email should be the pass.
I can pull up the first email you sent.
Yeah.
Well, you sent the Zoom link, passcode 793-764.
Yeah. So it's 4, 9. We're gonna add 20, so it's 4, 9. We could just copy this. And then it's gonna be 20.
Oh, sorry, one sec.
It's okay.
All right. Okay. I don't want to hear.
Too. So we have 4 now. And then after we add 17, it's going to go over here, but then it has to pro up since it would make this m equals 4. So it would be like this. And then we'd add 6. 6 would go over here, except it's too large, so we send 4 upward.
Can you guys hear me?
Yeah.
I'm joined on the iPad now, so I can start drawing out what you have.
Okay. Yeah, I think, what is it? 9 is going to be on the top, or
Are you on the last one?
yeah.
So you added 6 and then
4 moved up. Oh, wait, no. This 6 goes over here. 6 goes over here. And then 4. Then 12 will go over. These are not part of the same node. 17, 20, and then 9 would be on the top, I think. Or, well, yeah, I think that's right.
I think that makes sense, yeah.
Yeah, because 17 would go here. These are not part of the same node. So yeah, I guess I'll add more space. Yeah, so we can. We're gonna presume it's 3 because it doesn't say.
Do you want to just submit that, or do you want me to draw it out?
I think it's better to draw it out.
Okay. Let me. Should be able to share my screen, I think. You have to enable.
Yeah, I have to stop sharing too. There we go. Oh yeah, can you share your screen?
Yeah, it's starting in like 2 seconds, I think.
Okay.
And then if I go horizontal, can you guys see notability? Okay, you can.
Yeah.
Okay, so let me pull up the Word doc so I can read what's going on. So
Yeah.
initially you have 4 and 12.
Yeah, because we're having a max degree of m equals 3, right?
Yeah.
I'm presuming that's what they mean.
Assumed max degree 3, right?
Yeah.
And then you start, there's the,
yeah, max degree.
okay.
Yeah, so we have 4 and 12 initially.
Yeah.
And then we add 9. And then
4, 12, like that, right? That's what it looks like.
Yeah. And then we would add 9 to it, but then m would become 4 since we have 4 pointers. And so after adding 9, we're going to promote 9 because it would be in the middle. And then we're going to split 4 and 12. 4 is going to be on the left of 9, and 12 is going to be on the right of 9.
Okay. So I guess I didn't need to draw that out. There's 9 at the top. And then it has the pointers on the left and the right, right?
Yeah, 4. Yeah.
Actually, yeah, do we need to draw all the steps? I'll just draw the final one.
Yeah.
And then we can double check our work once the final one is drawn out. So there's 9 at the top. And then there's
4 on the left.
Dude, sometimes it does a square, other times it doesn't. It's so weird. And then 4. And then please, nice. Okay. That is not a square.
I think it's good enough.
I just deleted it because it was like awkward. Oh my God, are you guys seeing this?
Yeah.
It's giving me hell. Okay, and the one on the right is 17.
Yeah.
And then to the left of, I'll start with the left of 4. To the left of 4, there's a 2, right?
Oh, I think we should be drawing these in like the pointer sections. So like on like the 9 node, for example, it should have like a little, yeah. Okay,
Like
yeah,
that?
that's better. Yeah.
Okay, I can make those nicer looking. If notability would cooperate. It hates me today for some reason. It's just automatically connecting them when I didn't ask it to, but I can just redraw that. Okay. And then here, like that, right? 4, and then to the left of 4 is 2, right?
Actually, yeah, to the left of 4 should be 2.
Is there something you want to change?
I think 6 and 12, I think 4 and 17 should be part of the same node. I think.
Oh yeah, they should be. They wouldn't split up.
Yeah.
But would it be to the right or the left of?
Oh wait, no, never mind. I think they should be different because yeah, 9.
Oh, Jordan disconnected.
Oh.
Okay, I'll continue drawing. So okay. Let me draw 2 and 6. I'll just draw the pointers out even though it's empty.
Yeah, I think that's good.
Actually, I think maybe doing max degree of 3 is kind of cheating because that basically just makes it a binary search tree, right?
It doesn't need to be a binary search tree because right now each node is m equals 2. Okay, so I'm gonna probably go through this. So it's 4 comma 12. Then we split the node at 9. Then we add 20 on the right side of 12. And then we're going to add 2 to the left side. And then, yeah, we add 17 up. And so 12,
Okay, can y'all hear me?
12, 20.
Yes, we can hear you, Jordan.
Okay, cool. I'm gonna be using my phone because my laptop fan died, so it's
Okay.
really struggling to do anything.
Oh, BSOD's blue screen of death. Okay.
Yeah, one of my fans have died of the two, so everything makes it work overtime.
Right.
I tempted fate by doing Zoom, but that didn't want to work, so I'll just have to do it with my phone.
Okay. Well, you didn't miss anything. I'm still struggling to draw.
Okay, that's fine. If that's the case, I might have to ask you to draw for my question, if only so that it's visible for the lab video.
That's fine.
If not, then I'll just do paint and then send it.
Okay.
No, I can draw it. I'll get used to it. It's just acting up for me right now.
It's okay.
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 Yeah, okay. Looking at this, I think 4 and 17 should be the same node. And then we'd have, and then 6 and 12 would just be together, I guess. Yeah, that'll work, I think.
Well, I can do that, but I'm a little confused about, okay, let me disconnect.
Yeah, so 6 and 12 would be the same node. And then 2 would be at the left of 4, 17, and then 20 would be the right of 17. So yeah. I guess you can, yeah.
Okay, I'll just start over. What I was confused about was, so we have this node.
Yeah.
And then there's
a
4,
pointer on the left of
17.
4, and then there's a pointer in the middle. Yeah.
Right, I understand that part. I'm confused about from where of 9 would, like, which pointer of 9 should I be pointing to 4 and 17? Or actually, no, never mind, I'm being dumb. It would be like that, or like that, right?
Is that correct?
I don't know if 4 and 17 should be connected.
Should we start over from step to step?
Okay, yeah.
Let me see if I can pull up the Word document, because that might actually
I'm not sure.
help me remember the order.
Okay, so we insert 12 first, and then we insert 4. It's ascending order, so it swaps, and then we insert 9.
Yeah, we have to break it
and then
up.
it becomes 4, 9, 12. It's order 3, so 9 goes on top, 4 and 12 on the left and right, and then we add 20.
20 goes
At this
on the
point,
right.
we still haven't broken the order.
2 goes on the left of 4.
Right.
Then once we add 17, we need to split 12 and 20 up.
Well, you're skipping one step there. Once we add 17, 17 goes up top.
Oh, wait. So 17 would be a child right here, right?
Well, when it goes up top, it would join with 9, though. That's one of the things. Like,
okay, so it's like this.
Yeah, it might help if we go.
Would it be
sorry, say that again.
Oh yeah, you can continue.
I was just saying it might be easier if we like go through like this. He gave us steps to do it. If you go to page 7 of his document, an example of this specific situation is there. So 17 would go up to join up with 9. Yeah.
Yeah.
That part is fine. And then the left of 17 is 12. The right of 17 is 20. The left of 9 is 2 and 4. And then we add 6.
Yeah, we added 6. So originally that would be this right here. So I can do it like this. So we have 6 on the dock. Yeah.
Mm-hmm. And then because of that, 4 goes above.
4 goes above. And so we have 4, 9, 17 if they're the same node.
Mm-hmm.
Then 9 would go up. Okay, so it'd split the node, I think, right?
9 would go up. Oh wait,
Because it would
when
split the
9
4 and
goes up,
17.
2 and yeah,
4 and 17 would be split. So it should just
yeah,
be single nodes. Okay, yeah.
yeah. We
Okay.
had it right initially, so I'm just going to rewind a bunch of times here. Okay, wait, I think I'm good. So then it's 20.
Yeah,
Okay.
I think that's right. Yeah.
That should be
Like
okay.
save an image, or do you need me to take a screenshot? I can take a screenshot.
It would be easier if you took a screenshot because you can directly add it to the Google Doc. Yeah.
Okay, yeah. I will add the screenshot then. And put it on the doc.
Oh, sorry, let me know when you've taken it. I kind of scrolled with that.
Oh, I already took it. It's on the doc.
Okay. All right. Oh, awesome. Okay. Then what's the next question?
The next question is going to be this one. Copy paste it to the doc. So here's problem 2.
Max dig 3.
Yeah, I'll put this on a new page.
Wait. It says please create both to one paper and upload your work to this question. Okay. So there's 2 3s or 2 trees. Gosh.
Yeah. So are you drawing it on, or are we gonna?
I'm gonna do it on left and the right.
Okay. So what was it?
Okay. So it's a max degree of 3. So initially I'll draw it out like with the numbers like you did first, and then
I
I'll
think
draw
they're
it
all
out
part of the
properly.
same tree.
No, because he says, please create both on one paper and upload your work to this question.
No, I meant
So there's
like both are the same data. Like the BST and the B tree would both be this.
oh, BST and B tree. Okay. I didn't read the BST part. I was so confused as to what you were talking about. That's cool. That actually makes it easier for us. Okay. Well, if we're doing a binary search tree, we would start at the middle, right? For the first node, you would start at the middle?
Or yeah, the middlemost node. So
well, you would first want to
we could use
order it ascending order.
Yeah, we could do the Discord tree formula the way that he did it.
Yeah. So 15, 16. Is there a 17? No.
Or actually, oh wait, no, that creates a left, or I'm not sure. Well, I guess it is technically still a binary search tree. Yeah. Yeah. I'm gonna try and see what it would look like if you did it in order, like from left to right. So we'd have to.
I'm gonna continue ordering it. So in case we need to do that anyway, we're good. 56, 74.
Is that 97, or did you forget a 47 next to 43 on the first set of data?
I forgot the 47.
Okay.
Okay. So if we're doing like the original way, like for a binary tree, we could just start at 39 and then we just add nodes to the right or left.
Is it like not actually? That would probably be easier. And he never mentioned it had to be balanced. So
yeah,
I just thought it would be easier for us to draw it if it were balanced. So
it doesn't specify like a leftist heap or a Discord tree.
I mean, to be fair, if we did do the tree originally, wouldn't we have to balance it anyway?
The BST doesn't need to be balanced.
Yeah, okay. He didn't mention that. But I'm just gonna draw this out. 77. Oh. And then on the left is
16 would go on the left.
I just assumed that there was a left before I even drew it. Okay, I can draw the 16 in there, and then to the left of this,
56 would be 56.
yeah. And then 43 is on the
No,
right.
Yeah,
Okay.
so it could be on the left of 56.
Right. And then 47
That would
would
be on the
just
right of
go,
43.
yeah. Okay, I don't have the numbers on my screen anymore, so somebody's gonna have to tell me.
So after 47 is 42. So that's going to be on the left of 43. And then we have 74.
74.
So that's going to the right of 56. Then
15.
15, yeah. Then 23 is on the right of
3.
16.
Just want to take a screenshot of this real quick. Let me just erase that. Okay. Then I can move it all up.
Okay.
That's the first part.
Yeah.
He just said it had to be in one document, so it's fine if it's on 2 pages, I think. Or one file submission, sorry.
Okay. If we need to, I can just shrink it and crop it.
Yeah.
I'll make sure. Give us a good margin.
Okay, so I'll write this out with numbers first and then I can draw it out after.
Yeah. Or if you need me to, I can write it out with numbers.
That's fine. We can just talk it over as I'm trying it out.
So we have 39 and 77 first.
And then
56 is in the middle, so it becomes the parent, and then 39
56.
and 77 move to the left and right children.
Right.
Then we have 16 would go to the left of 39. Or let me create spaces. And then 16 would go to the left of this. And then this
43 would go to the right of 39. That would create,
so we need
that would move 39 up
bump
to
it up.
56. Yeah.
Yeah. So comma. And then 39 would go in the middle. There's no comma here anymore.
Wait,
Then-
wait, where are you getting? It's 43, not
Oh,
33. So 39 would move up, 43 would go down.
39 moves up, 43 moves down. Yeah, sorry about that.
No, you're good. Everything else was right. You just messed the numbers up a little. And then
47 would go here. I think.
well, 47 would just go left of 56, right? I think it's okay. Yeah.
Yeah, and then what else? Wait, are these part of the same node, 39 and 56?
Yes, they should be.
Okay. And then
They'll only split up when we add a parent
okay.
or when one of them moves up.
And then we would add 42. So 42 would go in the middle. And so 43 gets sent up, but we'll just, for ease, we'll just copy this and say 42 goes in the middle. 42 goes in the middle. And then so 43 would move up. And we're left with the problem that now we have m equals 4. And so we would move 43 up and split the tree, or split that node.
Think so.
Yeah. 43 would go here.
Let me draw this out for a second, just so we're all on the same page. So 43 at the top, 39, 56 split up, right? And then left of 39 is 16, right of 39 is 42 and 47, which is one node. And then right of 56 is 77, and these two are split up.
Supposed to go, how it splits?
That's what I was confused about, because the way you drew it out, I wasn't sure if 42 and 47 are in the same node or not.
Let me see how he does it. Because 08, 17. Okay, it moves up. Then it moves up. What exactly happened here?
What page are you looking at?
I'm looking at the added 45 to see how he split it when he added the parent.
45. I can't even find 45. So before that, it was.
Yeah, it's on page 8. It's the last one.
Yeah, I see it. I'm just trying to figure out what it was before exactly.
Yeah, so he added 45 to the 25, 26, 28, 29 node.
Mm-hmm.
And so that node got split and 28 was brought upward. And then 28's in the middle of this.
And that's
right. So 17 gets brought up.
Yeah.
Yeah. And then 28 took the left and right child. Okay. So looking at our example, 43 is going to move up, or yeah, so we have 42, 43, and 47. So that was pointing to the middle node right there. We added it, it went there. 43. Yeah, so we'd have 16, 39, 42. And then I think these are separate nodes. Like they're not the same node anymore. Because the point of the B tree was for balance, right? Yeah, and the node gets kind of split the way he does it. So the 25, 26, and 29 and 45, they're both in different nodes now.
Okay.
Yeah, I think that's how it works.
I think you're right. There's only like 2 numbers left.
Yeah, and then we need to add 74. So 74 would go on the right side of 56, joining 77. And then we add 15, which would go on the right left side of 16. And then what else? We have 23. 23 would join the left node of 39, but it can't do that, so 16 would become the parent. And then so we're left with this on the bottom. Yeah. So we could have 43, then then we have 16 and 39 to the left. They're the same node. And then 15 is the left child, 23 is the middle child, 42 is the right child.
Sorry, I was just redrawing it for my own sake because I was a little confused.
Okay.
But I think I'm almost caught up anyway. So I just added 47. So next is 42. So 42 goes in the middle, or 42 goes there, but
Yeah, so I have it
42
on the
goes
top.
where 43 and 47 are, and then you move 43 up because it's the middle one.
right. And I think, okay, I think I'm good now. Okay, so let me just draw what you have in the last step. So okay, please. Okay. What's the max? 3, right?
3.
Yeah.
M is 3.
So we have 43 at the top.
Mhm.
But before I do that, let me just copy this to make it easier on me. More consistent.
Yeah, so we're gonna have 2 double nodes. That's gonna be the 16 and 39, which is to the left, and then another double node on the very bottom right. Yeah.
And then
Yeah, so it's gonna be below that. It's gonna be to the bottom right of that node.
sorry, one sec. So should I head 56 to the left or right? I guess it doesn't matter. So
56 should be to the right, and it's just gonna be a single node.
should be to the right, like there.
Or, so
That's what I was
43 is
saying.
gonna be a single node. Yeah. So yeah.
Oh, yeah, it doesn't need to do that. So it's just 43.
Yeah, and then
then
56
this.
is a single node.
Yeah.
And then that node
And
to the
then
right of it is going to be 74 and 77.
Mhm.
So yeah, I think you'd have a pointer going down to it. Oh, and then yeah, that's going to be a single node containing just 42 or 47. Yeah, you might need to make it smaller because you're going to have 42 that's going to be to the right of 39.
I can make them all smaller here. Here, let me just do this.
Or I mean, because you need to draw a node to the right of 39.
Yeah, sorry, I was just making them smaller so I can move them around more.
Oh, okay.
Yeah. And then single node to 40 to the right of 42, right?
Yeah.
Or to the right of 39.
Yeah. And then in that middle node between 16 and 39, there's going to be 23.
Oh, okay. So another single node.
Yeah, another single node. So it might be better to just make 42 smaller.
Yeah, I will in a second. So this one is 23, right?
Yeah, and there's going to be a node to the left of 16, which is 15.
And that one's a single node too?
Yeah.
Shoot. Okay, so like that, like that, like that, like that, that, that.
Yeah, that looks good.
Okay, it's a little ugly, but I don't want to waste more time on this.
Okay.
Let me know when you have the screenshot.
I'm gonna get it. Okay, I got it. And then, so I guess we could just make this shorter. Yeah. So we'll just say that this is the B tree, and then here's the BST. So yeah, we could probably just I don't know, save this as a screenshot, one giant screenshot later. And then problem 3 is gonna, I think problems. And then it says, why will a B tree always be shallower than a BST at the minimalist max degree? So I'll put this for problem 3.
Oh, well, if it's writing, then are the rest of the 3 questions just writing and no drawing?
Yeah,
In
the
which
rest of
case
them
I
is
can just stop.
Yeah,
Okay.
it's all writing.
Let me stop sharing my screen then. Oop. And let me also exit the call.
Okay, since my computer can't do anything besides super basic tasks, are you guys able to read me the question and then I'll try to answer it for like question 3?
Okay.
Sorry about that.
So for problem 3, it asks, I'll put it in the chat as well, but it asks, why will a B tree always be shallower than a BST at the minimalist max degree? So I guess I'll share. Yeah, so the B tree will always be shallower than the BST at the minimalist max degree. So that just be, so the minimalist max degree, so the minimalist M is what it means. And so that should just mean the most minimum M. So does he mean 2 or 3 for M? Well, I guess the B tree always balances itself, right?
Yeah. It has no choice but to.
The B
Hey,
tree.
sorry, can you guys hear me now?
Yeah, I can hear you.
I've been talking for a second and you guys can hear me, I don't think. Okay, sorry, continue.
Yeah, so the B tree will balance itself. And the BST will not balance itself. So this causes the depth of the B tree to be less of the BST, and therefore the B tree is always shallower than the BST at the minimalist max degree. Does that sound good? Yeah, because we saw it over here, the B tree is always balanced, while the BST is just like a bunch of things.
Yeah.
Yeah, since the B tree can also hold more data.
I mean,
one like level, I guess.
Yeah. And we can also just compare the heights of the things we made. The height of the BST is what, 4, 5, 6? It's 6, I think.
Yeah, and this is only 3.
It's 5 or 6 either. And yeah.
Yeah. And then for example, this can be easily seen in problem 2.
3. Question 3. Or is it 2? It was 2. My bad. You were right. My bad.
2, where the B tree balances itself and is shallower. And then, yeah, and then I think they get the point. So I'll just put this in the quiz. And so question 4. So the internal node means it's not a leaf.
Right. Why can't the root be an internal node? Oh, the root can't be an internal node because sometimes it would have it might not have children. Like if the root node is by itself, then the root node is the leaf, in which case it's not an internal node, right?
Oh, yeah, because it would just be a leaf.
Yeah. I don't know if that's what they're looking for, though. I think that
Yeah.
makes sense, but I don't know if that's exactly what they're looking for.
I think they have the rule for the have between m/2 and m subtrees.
Have between m/2 and m subtrees.
Oh yeah, so here's the thing. The root is a leaf. And an interior node can't be a leaf.
Okay. So what I said was right. I just didn't include the 2 and m subtrees thing.
Yeah. So we could probably just copy this.
Yeah, because I would first define what an interior node is, and then you can talk about the m/2 m subtrees thing or whatever.
Okay, so an interior node cannot be a leaf. However, the root can be a leaf. And then an interior node must have between floor, or I think this was ceiling, right? m/2, yeah, ceiling.
Yeah. Sorry, I was a little confused between that and because there's another one that takes the floor, right? That's why I was like, okay.
Yeah, if it goes upward, it's ceiling.
Yeah. No, I mean, because like in the calculation, when you're doing the splitting of the trees, you do floor. Whereas
Oh
for this one,
yeah,
you do ceiling. That's why I wanted to make sure I had the right one.
it's kind of weird.
Yeah.
Meanwhile, the root node can have between 2 and m subtrees, right?
Well, it can have 0 subtrees too.
Well, yeah, that too.
Oh, but you mentioned the leaf above.
Yeah. If it's not a leaf, if the root's not a leaf. So yeah, I think that answers this question, right?
Yeah.
So yeah.
I would just mention like the root is a leaf when it is the only node in the tree. Just I mean it's kind of self like
Yeah.
evident, but
In the tree.
yep.
Okay, I'll copy and paste this. Okay. In problem 5, key node is deleted. What possible changes will have to be done within the B tree? Oh yeah, that's at the very end.
Wait, real quick. When he asked us to draw the B trees earlier, did he want us to draw it like the one on the first page or the way we drew it? Because the one on the first page has like when it's the hard drive memory, it's the vertical stack.
Oh, well, the issue, well, I think we're only concerning ourselves with like internal nodes. Like he didn't say anything about like the disk blocks,
Okay.
like the data leaves, I guess.
Yeah, I just wanted to make sure.
Yeah, because
Because
he didn't say anything about like records.
mhm.
Yeah, so these pointers would be pointing towards records, and then he didn't say anything about that.
Right.
Unless he
Okay.
wants us to design that.
No, I mean he didn't mention it, so let's not worry about it.
I mean, I guess we could just like add a disk block. I don't know, but it seems unnecessary. It's
mhm.
like, yeah, because these records are not the same as like the leaf. You have 1, 2, and 4, and they're not the same. And then we don't even know what L is because he didn't say. Yeah, he didn't give us L, so I'm gonna presume that he didn't want it.
Okay. How much time do we have, by the way?
I think we started somewhere around 2:20
So we have like 30
or
minutes.
2:25. Yeah. So if a key node is deleted, what possible changes will have to be done to the B tree?
This example is actually shown, I think, at the end, right?
Yeah, deleting.
Like at the end of the document. It wasn't in the video, so.
Yeah, key node is deleted. So yeah, it depends on what kind of key are we deleting. Yeah.
Okay, so there's a lot of situations that he mentions.
Yeah, so do you want to just go through each case, or because these are all keys?
Mm-hmm. Maybe can you go back to the question, or did you paste it in the Google Doc
I
already?
pasted it in the Google Doc, or I don't know if I did.
You did. If a keynote is deleted, what possible changes will have to be done with the B tree? We would suggest that you draw or gather few examples to help this question. So I think it would be best to list out each of the situations that he has in the there. I'll type that out real quick.
Okay, I'll stop sharing.
Yeah, you can even like snip tool the examples he uses. Because I mean, he says provide examples, but he didn't say you couldn't use his technically, and he goes over pretty much all of them. So
yeah, let me share my screen real quick. Give me 1 second. Can you guys see my screen? It's happening. Case 1 is deleting a key that is a leaf. Then case 2 is deleting a key that is not a leaf.
Yeah.
And then deleting a key that is a leaf. Wait, hold on 1 sec.
Case 2 is no underflow. Case 3 is underflow.
Oh.
Or well, actually.
Avoiding underflow. No underflow.
And then case 3 is steal from child or steal from bigger sibling.
Underflow, steal from bigger sibling.
And then case 4 is also deleting the leaf. Underflow, and then merge the sibling in parent.
Okay, what did I just do? Wait, is it still here? It is still here. Okay.
Then case 5 is multiple of the other cases. So yeah.
Wait, where is case 5? It's not like specified.
Or it's, well, I guess it's technically in deletion. It's always the leaves really.
I'll leave that as it is for now, and then we can figure it out as we type it.
Okay.
Okay, so let me scroll back up to case 1.
So yeah, so what is it?
Since the leaves do not need to follow the m to m over 2 rule,
we can just delete the leaf.
We can just delete the leaf in question.
Yeah, I think it's the leaf, but it has like another node. Yeah, it has another key. So deleting a key that is a leaf that has another key with it. So for example, they have 3 and 4. So we can delete 4 and that's okay
Mm-hmm.
because 3 will still be there and then
Right.
2 will still have its children.
Right. So for example, if a leaf had aren't we kind of assuming something though?
With another
Here?
key in the same leaf.
Yeah.
Yeah. Yeah, so
Say the leaf in question had the values
3 and 4.
5 and
Oh,
6.
yeah, 5 and 6.
If we were to delete 6, then the
Parent node would
key,
still follow M to M over 2 rule.
yeah, then the key 5 would be used, and the parent node would still follow the M to M. Is that everything we want to cover for that case before we move on? Okay. Okay.
And then case 2, deleting a non-leaf key. So yeah. What is it?
When deleting a non-leaf key, once the node is deleted, promote the left node's largest value.
Or it depends.
Value.
Yeah.
I'm just writing off of exactly what's in key 2.
Yeah, because if you delete, this is if you delete the leftmost node. So I think you always delete what is it? Yeah. What happens if they delete 13? Yeah. They end up bringing, yeah, they brought 12 up.
Which is to the left of 13 and is the
Oh,
highest
yeah.
value. So the key,
Okay.
this
Yeah.
still applies.
Yeah.
What is underflow here when he's referring to?
So I think that's when the M over 2 rule gets violated. So like you delete a node. So like, for example, on the 3 and 4 or the 5 and 6, if the 5 didn't exist, the parent wouldn't have a child anymore. And so there's an underflow.
Mm-hmm.
Yeah, I think that's what he explained in the video. Yeah, or it's when no key is left in a node, when target key deleted. That's what it means.
I.e., no key is left in the node.
Yeah.
The parent is demoted. Let me do the same thing with the promoted. Demoted to where the node was just deleted from. In turn, at the same time, promote the closest sibling. So in their example, 1 was deleted, 3 was promoted, and 2 is a sibling of 4, and that was.
Yeah, so if 21 got deleted, I think we would send 9 and 13. I can check real quick. Yeah. Well, I guess we can't because there's no video, but
I'm just, so in turn, at the same time, promote the closest sibling In the document, he says allude to the parent. I don't know what allude means.
So what do you mean allude?
Well, he says in the document on page 34, he says allude. I don't know what the allude means.
I think that's just a typo and he just means closest sibling to parent.
Okay, but that's
It's
not
not
what
that-
shows. Is that what shows in the diagram?
Yeah, here goes to.
Oh, demote parent and then promote the closest sibling to the parent. Okay, yeah, that makes sense.
Yeah.
In turn, I should. This isn't at the same time, right? After promote the closest sibling to the now demoted parent to where the parent was originally. Previously doesn't make sense, right?
Yeah.
Okay, fourth case.
And then cleaning a key that is a leaf, an underflow. So deleted 21. And then 10 and 13 went away. Yeah, you can't really steal from the sibling because it's if you delete from the sibling. So yeah, so we're presuming that the sibling has more than one node. So I'll write that there. Because sibling only has one node or one key. And so that's why that's there for case 4. Because you can't, if you get the node from if you get the node from the sibling and only has one key, you're left with another underflow error because the sibling's just gone.
Okay, so what exactly do I type here?
Yeah, so yeah. We're just gonna merge the closest sibling and the parent and then demote newly merged keys to the deletion location. I think it's just what he has on the doc. Yeah. And the reason we have to do this is because we can't steal from the sibling. Otherwise, the sibling can't steal from the sibling because if we reason we have to do this is that you can't steal a sibling because the sibling would become empty and another underflow would be generated. Yeah, so you can see that in an example. If you tried deleting 10 and moving it upward, we'd have an issue because 10 would be empty.
Yeah. Also, I was gonna say the last case 5 is just like
Multiple
sometimes
cases.
you have to, you have to do multiple cases one after the other. So I don't think that really counts as a case.
Okay.
So I can just say like finally, sometimes you might have to do one case right after the other because executing one case result in the production of another case. Does that sentence make sense to you?
Yeah, I think it makes sense. You want me to put in the doc?
Yeah.
Yeah, no.
I'll stop sharing my screen so you can, I think that's the final question. So you can upload the first two questions pictures and then we're good to go.
Hold up. Let me see. Yeah, I'd have to retake the image or I have to retake the screenshot. That's okay, I guess.
Yeah, let me know if you want screenshots from the Notability for whatever reason, if it doesn't work from the Google Doc. Also, you're not sharing your screen, by the way, just so you know.
Oops. Yeah, hold up. Hold up. I need to access my files.
You're good, take it down.
Tab 9. Yeah, hold up. Let me share my screen. I will take a screenshot of this. Well, that's not useful. Let me make the full thing. And then, or let me exit out of that. There we go. And then, yeah. And then go over here. These are all on the same paper. I just need to get my view.
Just do Control minus and it'll zoom out.
Oh, nice. So I can do this. There we go. We have our BST and the B tree. And this is question 2. And then we can go over here, quiz 2. Not necessary. That's wrong course. It would be this. Lab 9. Question 1. And that'd be question 2. And then we can see it here. We have our B tree and our BST in the B tree.
Mm-hmm.
We have all of our answers.
Looks good to me.
Yeah, case 2, case 3, case 4, then the finally. Ready to submit?
Yep.
Okay.
Jordan disconnected again.
Oof.
Yeah.
Yeah, and then we'll probably get a 0 because it needs to be graded. Yeah. Yeah. So we have a 0 right now. And then I will, I guess, do you want me to, who's going to do the survey for this week?
I was going to say it should be Jordan because I did the last 2. We can probably just tell her over text. And if she can't, for whatever reason, I can do it.
Okay, I'll send both of y'all the video then.
All right.